Hi everybody, in this video, let's learn about how do we use definite integral to help us to get the area of a region. If you want to find the area bounded by a curve, straight line, and x-axis, we use y dx. Okay, x-axis we use y dx. So you will see here I write f of x dx is the same thing because y is equal to f of x. If this is dx, these two numbers are taken from x-axis. Okay, so if you want to find the area bounded by a curve, straight line, and y-axis, x dy. This is dy. These two numbers are taken from y-axis. So remember, area bounded by a curve, straight line, and x-axis, dx. Area bounded by a curve, straight line, and y-axis, dy. So this is x dy, this is y dx. But you need to be more careful when you use definite integral to find the area of a region. For this situation, y dx above x-axis, no problem, you will get a positive value when you find the definite integral with the lower boundary a, upper boundary b. So when you find the definite integral for this part, lower boundary b, upper boundary c, you will actually get a negative value. But we need to note area cannot be negative, right? So when you want to state the final answer for the area for this region, remember to modulus it, just take the absolute value of it. Take the number without the negative sign. Okay, now same thing here. When you want to find the area bounded by a curve, straight line, and y-axis, we use x dy. For right hand side, no problem, you will get a positive value. But when you find the definite integral for this part with the lower boundary a, upper boundary b, you will get a negative value. As I told you just now, area cannot be negative, right? When you want to state the final answer for area, remember to take the absolute value of it. Means that you just take the modulus, you just modulate it, take the number without the negative sign. Now, let's look at this very simple example so that you know better when do we use y dx, when do we use x dy. Okay, here we have two regions, region A and region B. Actually, you don't have to use a definite integral to find the area for region A and region B because this is just trapezium, right? We can just use trapezium formula to help us to get the area. And on the top here, this is a triangle. We can just use triangle method, triangle formula to help us to get the area. But here I'm going to show you both methods, then compare whether these two methods give us the same answer. Now let's look at the area of region A first. This is a trapezium, right? So we can just use trapezium formula. How many units here? This is 2 units. How many units here? This is 8 units. And here, 6 units. Area of region A. If you want to find the area of a trapezium, remember, always start with 1/2. Then find the sum of the two parallel sides, which is 2 and 8. 2 and 8. Then times the height, which is 6. Okay, just press your calculator. Here you should be able to get 30. This is the area of region A. So how about if we want to use definite integral to help us to get the answer for this for the area of region A? Straight line, here also straight line, and x-axis. So which formula we want to use, this one or this one? Since this is x-axis, right? dx, y dx. This is dx, so these two numbers, lower boundary and upper boundary, must be taken from x-axis, which is 0, 6. Okay, so what's y? Y is equal to x plus 2, right? X plus 2 dx. Okay, now we just do the simple integration, then find the value of this definite integral. X squared over 2 plus 2x. First, we're substituting the upper boundary inside this function first. So 6 squared divided by 2 plus 2 times 6. When you bring in the 0 here and here, you will get 0. Okay, 6 squared is 36. 36 divided by 2, you will get 18. 2 times 6, you will get 12. And eventually, you will get 30 as well. Both will give us exactly the same answer. Okay, now, how about if we want to find the area of this region B? First, let me use triangle formula. Area of region B. How many units here? 2 until 8, which is 6 units. How about here? This is 6 units as well. So remember, if you want to find the area of a triangle, also same thing, always start with 1 over 2 times the base length and times the perpendicular height. So here you will get 16. Sorry, not 16, 18. Okay, now how about if we use definite integral to help us get the area for this part? A straight line, here another straight line, and y-axis, right? So which formula we need to use? Area of region B. Y-axis, dy, x dy. So this is dy. These two numbers will be taken from the y-axis, which is 2 until 8. 2 until 8. X is equal to, but here is y in terms of x, since we need x, right? So we need to change the subject from y to x. Y is equal to x plus 2. Then we know that x is equal to y minus 2. We need to express x in terms of y, so that we can bring this whole thing go in here. Y minus 2 dy. Okay, then we can start to do the integration. Y squared over 2 minus 2x. Upper boundary 8, lower boundary 2. Okay, so bring in the upper boundary first, which is 8, and you need to square it. 2 times 8. Okay, minus, now the lower boundary turns. Bring in 2 here and here. So this is 2 squared divided by 2 minus 2 times 2. Okay, so just press your calculator. So this is 64 divided by 2 minus 16. You will get 16. How about here? 4 divided by 2 minus 4. You will get negative 2. 16 minus negative 2, it becomes 16 plus 2, which will also give you 18. Both will give you the same answer. Okay, so even though we can use this formula to get the answer, but in the exam, normally the question the question asked in exam will involve a curve like this. So we need to use definite integral to help us to get the area. If the question asked is about area bounded by straight line, for example, in like this situation, we actually don't have to use this definite integral. We can just use simple trapezium formula or triangle formula, depend on the shape of the area, to get the answer. Okay, now let's look at another example. Just now I told you that sometimes you get positive, right? Right hand side for this formula, x dy. Right hand side you get positive, left hand side you get negative, right? For y dx, above x-axis you get positive, below x-axis you get negative, right? Now let's look at this example. Let's find the area of A and the area of B. So first I'm going to use triangle formula. Area of region A. So this is 2 units, this is 2 units as well. Remember, to find the area of a triangle, always start with 1 over 2 and times the base length times the perpendicular height. You get 2. So if you want to find the if you want to use the definite integral to find this area, this is straight line and x-axis, right? So I'm going to use this y dx. Lower boundary 0, upper boundary 2. Y dx. Y is equal to minus x plus 2, negative x plus 2. Okay, now we start to do the integration. Negative x squared over 2 plus 2x. Bring in the 2, go in here and here. Well, bring in 0 here and here you get 0. Okay, so this is negative 4 over 2, which is negative 2 plus 4. You will get the same answer, which is 2 square unit. No problem, right? Okay, now we need to be more careful for this part. Let me use simple triangle formula first to find the area of region B. One over 2 times 4 times another 4. So you will get 8. How about we use definite integral to help us to get the answer? So same thing, this is x-axis, I'm going to use y dx. Let me use another color. Y dx 2 to 6. Y is equal to negative x plus 2. Okay, now we can start to do the integration. Negative x squared over 2 plus 2. Exactly the same thing here, just change the lower limit and upper limit. 6, 2. Okay. Now, first I'm going to bring in this upper limits first. Negative 6 squared over 2 plus 2. Oh, sorry, I make a mistake here. Here should be 2x. 2x. 2 times 6. Okay, so for this part, negative 2 squared over 2 plus 2 times 2. Okay, this one you can just press your calculator. Negative 36 over 2 plus 12. You get negative 6 minus copy first, and this part is actually equal to this 2. You will get negative 8, right? So area cannot be negative, right? If you start to write area of region B here, so it becomes area equal to negative is not correct. So you need to add a modulus sign here, or you need to add a modulus sign. So it looks complicated. So for this situation, I would suggest you to first don't write this, just start from here. Just find the definite integral. You get negative 8, right? Because this is below x-axis, as I told you just now. This one. Positive, negative. Positive, negative. So what we need to do to find the answer, remember to modulus it. Area of region B. Here we don't have to write anything first. Until the end, area of region B, then you can just write 8 units, or if you want to write one more step, modulus -8, then which is equal to 8 units. Okay, remember area cannot be negative. Now let's look at a few other examples so that you know better about this topic. The diagram shows a region which is bounded by a curve y equal to x cubed. The y-axis, and the line y equal to 0, y equal to 0 is over here, y equal to 0, and y is equal to 8. Find the area of the region. We want to find the area here, the shaded region. Here I'm going to show you two methods. So first method is I'm going to use this formula, curve and y-axis, right? So I'm going to use area of the shaded region. Before I start to find the definite integral, I know that this must be positive, right? Because right hand side. So at the beginning, I already can start writing this area of the shaded region. Y-axis, dy, x dy. So these two numbers will be taken from y-axis, which is 0 until 8. But do notice that here is x dy, right? We don't have x. We only have y in terms of x. So what do we need to do is to change the subject from y to x so that we can substituting here. Y is equal to x power 3. We cube root both sides, so cube root is actually equal to raised to the power of 1 over 3. Okay, so you will get x. Now you have a function which is x in terms of y. Now we can bring this whole thing go in here. Okay, now we can start to do the integration. 1 over 3 plus 1. Plus 1, it will be 4 over 3. Okay, here will be 4 over 3 as well. 8 over 0. So divided by 4 over 3 is actually equal to 3 over 4. This thing times 3 over 4. Okay, 3 over 4 times 8 raised to the power of 4 over 3 minus, bringing 0 here, 3 over 4 times 0 raised to the power of 4 over 3. Okay, so here you can just press your calculator, 8 to the power of 4 over 3 times 3 over 4. You will get 12 minus 0 raised to the power of 4 over 3 will still be 0. So 0 times 3 over 4, you will get 0. So the final answer is 12. 12 square unit. So this is one of the methods. So some students might maybe don't want to use this method. They want to use another formula, which is y dx. Here we also can use y dx to help us to get the area of this shaded region. Okay, let's see how do we do that. From here, I draw a straight line go down here. Okay, this is 2. I can find the area of this region first. Then I take the area of this rectangle minus the area of this purple region. Okay, let's see how do we get the answer. How do we use this method? So let this be A and this be B. Area of region B. So since that this is above above x-axis, we know that the definite integral will be positive, right? X-axis, so I use dx, y dx. So these two numbers must be taken from x-axis, which is from 0 to 2. 0 to 2. So this time no problem. Since this is y, we don't have to change the subject. Y is equal to x cubed, right? So we just bring this whole thing go in here. X cubed dx. Now we can start to do the integration. Power 4 over 4. So bring in the upper limit first. So 2 power 4 will give you 16 minus 0 power 4 over 4. 2 power 4 give you 16. 16 divided by 4, you will get 4. Minus 0, so you still be 4. But this is not the final answer yet, because we are looking for the area of this region, not here. Let me find the area of the rectangle first. This whole rectangle, which is 2 times 8, will give you 16. Now, since I am looking for the area of region A, area of region, okay, area of J region. Okay, area of region A is equal to the area of this rectangle, which is 16, minus the area of this purple region, which is 4. You still get the same thing, 12 square units. Okay, both methods give you exactly the same answer. The diagram beside shows the curve y equal to x parentheses x minus 4 parentheses x plus 2. Find the area of the region bounded by this curve, the x-axis, and the line x is equal to 3. X is equal to 3, which is over here. This is 3. So we are looking for the area bounded by this curve, x-axis, and this straight line, which is over here. Okay, so can I do it this way? Area of the region, area of the region. From negative 2 to 3. To 3. Then since this is x-axis, right? So y dx. Can I do it like this? No, you cannot do it this way. Because one is above, this region is above x-axis, which will give you a positive value. And this region is below x-axis, which will give you negative value. If you do it like this, the answer will actually take this one minus this one. Eventually, you get a wrong answer. Okay, let me show you here. Here I need to do them, get the area of these two regions separately. Let me label this one as region A and this as region B. Area of region A. Before start to find the definite integral, I know that I will get a positive value because this is above x-axis, right? X-axis dx, y dx, and since this is dx, These two numbers must be taken from x-axis, which is negative 2 to 0. Okay, y is equal to this. So first thing, I'm going to expand this one first. Y is equal to x minus 4, x plus 2. Okay, let me do the expansion first. X times x will give you x squared, x times negative 4, negative 4x. X squared times x will give you x power 3. X squared times positive 2 will give you positive 2x squared. And negative 4x times x, negative 4x squared. Negative 4x times 2, negative 8x. Okay, then we do some simplification. Like terms, we can simplify them. So here will be x cubed plus 2x squared minus 4x squared will give you negative 2x squared minus 8x. Okay, now I can bring this whole thing go in here. Negative 2, 0. Y is equal to this, x power 3 minus 2x squared minus 8x dx. Okay, now we can start to do the integration. X power 4 divided by 4 minus 2x power 3 divided by 3. Remember the power, we need to add 1. So 3 plus 1 you will get 4. Whatever you write here, write the same thing for the denominator. So you remember this one? Okay, 8x power 1 plus 1 you will get x power 2. And here you write the same thing, which is 2. Okay, so let me simplify this one first. 8 divided by 2, which will give you 4. First, we bring in the 0 go in here. Replace all the x by 0. 0 to the power 4 divided by 4 minus 2 over 3 times 0 raised to the power of 3 minus 4 times 0 square. You notice that this whole thing will actually give you 0, right? Negative 2. When you deal with negative number, you need to be more careful. When you key in the calculator, remember to put a parenthesis. Negative 2 power 3 minus 4 times negative 2 square. Okay, here will give you 0. Remember to copy the negative first, then press your calculator for this part. Here you will get negative 20 over 3. Negative, eventually you will get a positive value. So as we expected, here will give us a positive value. Now we need to find the region for part B. Before we start find the region for part B, we know that the definite integral will give us a negative value, right? Because this is below x-axis. Area of region B. Okay. So the beginning integration process is actually the same. What we just need to do is change the lower limit and upper limit. Still same. Oh, I don't want to write area of region B first. Why? Because I know that this is negative, right? Area cannot be equal to negative. I don't want to write anything first. Just start with the integration. So this is y dx. I don't have to write y anymore. Just copy this whole thing. X power 3 minus 2x squared minus 8x. Lower limit 0. Upper limit not 4 but 3. So this we want to integrate it, right? So we don't need to do the integration again. We can just copy from here. X power 4 over 4 minus 2 over 3 x power 3 minus 4x squared. But this time the lower limit is 0, the upper limit is 3. Okay, just bring in 3 here. 3 power 4 minus 4 minus 2 over 3 times 3 power 3 minus 4 times 3 square. Minus this whole thing, when you bring in 0 here, all will give you, this whole thing will give you 0, right? Okay. So just press your calculator for this part. You should be able to get negative 135 over 4. So as we expected, this region, when we find the definite integral for this part, because this is below x-axis, it will give us a negative value. So now we want to answer the questions. The area of the region bounded by the curve, the x-axis, and the line x equal to 3. Total area. Or you can write area of the or we cannot write area of the shaded region because the diagram does not shade the region. Okay, just write total area. 20 over 3 plus, remember the modulus is. You can write modulus negative 135 over 4. If you don't want to write modulus negative 135 over 4, you can just write 135 over 4. Take the number only without the negative sign, because area cannot be negative, right? Okay, just find the sum of these two numbers. The final answer is 40 and 5 over 12 square unit. Okay, this is final answer. So what will happen if you take negative 2 as a lower limit and 3 as the upper limit? You don't want to do it separately. You will actually get the wrong answer. Okay, let me show you here. So this one I just use calculator to show you. I find the definite integral. Key in this whole thing, go in, whole thing inside x power 3 and then minus 2x squared minus 8x. Okay, with the lower limit negative 2, upper limit 3. Let's see what answer will we get. We will get negative 325 over 12. Negative 325 over 12. We know that this is definitely not a correct answer, right? Because area cannot be negative. But why the calculator will give us this answer? Because it's actually take this one plus this one. You get this. You can try press your calculator. 20 over 3 plus the negative 135 over 4. So eventually you get negative 325 over 12. So which is not correct. Okay, this is not correct. So remember, if you see this type of situation, one area is above x-axis, another area is below x-axis, we need to do it separately. Okay, now let's look at another example. The diagram shows a curve y squared is equal to 9 minus x. Find the area of the shaded region. Again, one is left hand side of the y-axis, another one is right hand side of the y-axis. We know when we find the different integral, right hand side will give a positive, left hand side will give a negative, right? So we need to do it separately as I told you just now. Okay, now let me label this as region A and this as region B. Area of region, let me write over here. Area of region A. So we know here must be positive, right? When we find the definite integral must be positive. since this is a curve, straight line and y-axis, dy, x dy, and these two numbers must be taken from y-axis, which is -1 until here. But the problem is we don't have this number. We need to find it first. Y squared is equal to 9 minus x on y-axis. X is equal to 0. I'm going to substituting 0 inside here. Y squared is equal to 9. Y is equal to plus minus 3. We get two answers because one is over here, -3, and then one is over here, which is +3. Okay, now we know the lower limit is -1, upper limit is 3. Y is x. Again, we don't have the function here is actually y squared is equal to 9 minus x. So we want to change the subject become x. Express x in terms of y. Y squared is equal to 9 minus x. I bring the negative x over here, become positive x. 9 copy. Y squared bring over here, become negative y squared. Now we have a function x in terms of y. I'm going to bring this whole thing inside here. 9 minus y squared dy. Now we can start to do the integration. (9y minus y power 3 over 3). 3 minus 1. First, we substitute the upper limit inside here. So 9 times 3 minus 3 power 3 over 3. Now, the lower limits turned. Bring in this one, -1 inside here. Minus, remember to write minus. 9 times -1. Oh, yes, correct. So actually, if you want to use a calculator to help you for this part, right, you can just key in this function 9, but you don't have to key in y, you just key in x minus x power 3 over 3. Okay, now we want to calculate when we substituting the y with 3, right? Just press calculate, then key in 3, press equal. Again, you get 18. Here you get 18. Copy the negative. Here do the same thing, press calculate. Since we already have the function, what do we need to do is to change it to -1. -1. Press equal again. So you will get -26 over 3. -26 over 3. Just press the calculator. 18 minus -26 over 3 means plus 26 over 3. Okay, so the final answer will be 26 and 2 over 3 square unit. Oh, this is not the final answer yet. This is only the area for region A. We still need to find the area for region B. Now, let's find the area of region B. Area. Let me use another color. Okay, now I know that this must be negative, right? So at the beginning, I don't want to write area of region B. I just find the definite integral for this one. 3 to 4. 3 to 4. And then y-axis, right? X dy. The beginning step is the same as this one. We can actually just copy this one. 9y minus y power 3 over 3. But we change the lower limit and upper limit become 4, 3. Now we are going to bring in the upper limit, which is 4. 9 times 4 minus 4 power 3 over 3. Minus 9 times 3. Oh, this is not y, but 3. minus 3 power 3 over 3. Okay, so as I told you just now, we can actually use our calculator to help us since we already have the function here, right? Just press calculate. Let me check the function correct or not. 9y, okay, minus, okay. Calculate, key in 4, press equal 2 times. You will get 44 over 3. 44 over 3 minus, press calculate, now key in 3, press equal 2 times, you will get 18. (44/3) minus 18. You will get a negative answer as we expected because this is on the left hand side of the y-axis. And remember, now we want to find the area of the shaded region. We need to add up these two area. But remember, we need to modulus it. Area of the shaded, okay, let me write again. Area of the shaded region, 26 and 2 over 3 plus, don't take the negative sign, we only want the number, we just take the absolute value of it, 10 over 3. Okay. The final answer is 30 square units. So just be more careful when you see one side on the left hand side and the side on the right hand side. Same thing as just now. One side, one region above x-axis and a region below x-axis. We need to calculate them separately. Okay, now let's try one more last example. The diagram shows a graph of y is equal to x squared plus, minus 5x plus 9, and y is equal to 9 minus 3x. This is a straight line, this is a curve. We want to find the area of the shaded region. So here I'm going to break this area become two parts. This is region A and this is region B. For region B, this is a triangle. I'm going to use triangle formula to help me to get the area. But I need to know what is the value here and here, right? And also here. Then only I know the height of the triangle and the base length of the triangle. Y is equal to 9 minus 3x. Let me find this value first, the x-intercept of this straight line. On x-axis, y equal to 0. So this is equal to 0. 9 minus 3x. 3x is equal to 9. X is equal to 3. So now I know this is 3. The second thing that I'm going to find is the intersection point between the curve and the straight line. So we want to find the intersection point between the curve and the straight line. We need to solve them simultaneously. So we have two functions here. Y is equal to x squared minus 5x plus 9. First function. Second, y is equal to 9 minus 3x. Second function. Okay, substitute the second function into the second equation into the first equation. Y is equal to 9 minus 3x. So here I'm going to change it become 9 minus 3x. 9 minus 3x is equal to x squared minus 5x plus 9. This is a quadratic equation. So I just need to rearrange this quadratic equation, write it in general form. Then we can start to solve it. x squared minus 5x plus 9 plus 3x minus 9. Okay. X squared. Okay, we don't have any other x squared, so just copy x squared. Minus 5x plus 5x, so this is 3x, sorry. So you will get negative 2x plus 9 minus 9, you will get 0. This whole thing is equal to 0. Do some factorization here. X is equal to 0 or x minus 2 is equal to 0. X is equal to 2. Now we know this is equal to 2. Why is not equal to 0? Because another point with 0 is here, right? We are not interested on this point. So we are interested on this point, so 2. So what is the value here? We can take this value, put inside this equation to help us to get the value of y. When x is equal to 2, or you can just write it this way. Substitute x equal to 2 into the second equation. Y is equal to 9 minus 3 times x. But we know that x is equal to 2, right? 9 minus 3 times 2, which is equal to 3. Okay, so first let me find the area of this part. Can I see it? Oh, I use this one. The area for region A. A curve and x-axis, right? Okay, so I'm going to use dx. Y dx from 0 to 2. 0 to 2. Y is equal to this. X squared minus 5x plus 9 dx. Now we can start to do the integration. X power 3, the power you just need a plus 1, whatever you write here, write the same thing for the denominator. 5x squared over 2 plus 9x to 0. Bringing the upper limit, which is 2 power 3 over 3 minus 5 over 2 times 2 power 2 plus 9 times 2. When you bring in 0 here, you get 0. Okay, just press the calculator for this part. You will get 32 over 3. Now, this is not the final answer yet. We still need to find the area of the region B. So since this is a triangle, I just use a simple triangle formula. Area of region B. 1 over 2 times base length, which is equal to 1, times the height, which is equal to 3. So this is 3 over 2. Now I just plus what I need to do next. Just plus these two areas together. Final answer is over here. Area of the shaded region is equal to 32 over 3, area of the region A, plus area of the region B, which is 3 over 2. The final answer is 12 and 1 over 6 square unit. Okay, so that's all for this video. Hopefully you understand better how do we use direct integral to find the area of a region. See you next time. Thanks for watching. Bye bye.